this video we're going to have a look at some more index laws. In the first video we looked at the first three index laws. When multiplying indices with the same base, we add the powers. When dividing indices with the same base, or we could write as a fraction, we subtract the powers. And when we have a power to a power, we multiply the indices. Now we're going to have a look at powers of products. That is, for example, 3 times 2 to the power of 5. Now what this means is 3 times 2 times itself 5 times. If we rearranged, we could see we have 3 times 3 times 3 times 3 times 3, which is 3 to the power of 5, times 2 to the power of 5. The shortcut here is a power of a product is the product of the powers. That is, we multiply in. Let's do another example with algebra. Suppose we have x squared times y6, all to the power of 3. Now, note the multiplication sign may be omitted here. Noticing that we multiplied in, we actually multiply the product, or find the product of the powers. That is x to the power of 2 times 3, which is 6, times y to the power of 6 times 3, which is 18. And your final answer, you could omit the multiplication sign. So we can write a rule here for the power of products. Like I said, a power of a product is the product of powers. This law can be useful to calculate answers more quickly. I'll show you an example. Suppose we were asked 5 times 4 squared. It may be quicker, possibly, to go 5 squared times 4 squared, which is 25 times 16, which is 400. Possibly not. We can also use this law in reverse. Suppose we had 5 to the power of 4 times 2 to the power of 4. We can then use this in reverse and find, using order of operations doing the brackets first here, 10 to the power of 4, which is 10,000. Next index law we're going to have a look at is power of quotients. Suppose we had 2/5 all to the power of 4. This is like saying 2/5 times 2/5 times 2/5 times 2/5. Here, multiplying our numerators, we would have 2 to the power of 4 over 5 to the power of 4. So a power of a quotient is the quotient of the powers. Writing this as a rule, A over B m equals AM over BM. And like our power of products, if our factors already have powers, for instance using algebra, say x squared over y cubed to the power of 4, we simply multiply the indices. So now we have x to the power of 2 times 4, which is 8, over y to the power of 3 times 4, which is 12. I'll do one more example. Suppose we had 8 to the power of 3 over 2 to the power of 3. Now we could work out what 8 to the power of 3 is and then divide it by whatever 2 to the power of 3 is. But using this rule in reverse, we can go 8 over 2 to the power of 3. Well, that's a lot easier. 8 divided by 2 is 4 to the power of 3, which is 64. And our final one we're going to have a look at today is known as the zero index. We know, for instance, that 25 over 25, or any number over any number, equals 1. But let's put this in index form. 25 is 5 squared over 5 squared, so we know it equals 1. Using the quotient index law, when we divide numbers with the same base, we subtract the powers. So looking at this middle example, 5 to the power of 2 divided by 5 to the power of 2 would be like saying 5 to the power of 2 minus 2, which is 5 to the power of 0. And we know that this equals 1. So therefore, we can say that any number to the power of 0 will equal 1. But a cannot equal 0 because 0 to the power of 0 equals 0. So let's have a look at a few examples here. We can say that 7 to the power of 0 equals 1. We can say that a to the power of 0 equals 1. We could say 2 times 3 in brackets, all to the power of 0 equals 1. But don't be tricked here. What if I said 5 to the power of x, 5 times x to the power of 0? It's only the x to the power of 0 that equals 1. So in this case, it would be 5 times 1, which equals 5. So be very careful to look what is to the power of 0, because it's only that component or that term that equals 1.